Hello! I have to tell you guys, Isaac's not going to be in this one. I begged him to be a part of this, and he said that he did not want to. He is playing in his room. But what's probably going to happen since I'm sitting on the floor is you'll see one, if not two cats. So I hope that brings a smile to everyone's face. So our Chapter 12 test is all about geometry. We're going to talk about triangles, quadrilaterals, and we're going to talk a little bit about volume. So we know when we're looking at triangles, there's two ways we can classify them. We can classify them by their angle, or we can classify them by their side length. So I have three triangles here, and we're going to classify each of them first by angle and then by side length. So let's think about angles. There's three types of angles. We can have a right angle, we can have an acute angle, or we can have an obtuse angle. Okay? So this angle is larger than a right angle, so we know it can't be a right angle. And the word for something that's larger than a right angle is obtuse. So easy peasy, this is an obtuse triangle. Okay? Next, we have this one. And most students know that it has a nice square corner like that. That means it is a right triangle. Okay? And that, of course, leaves this one. All of the angles are acute. Okay, so the main difference to remember here is that a triangle can have more than one acute angle. In fact, it will always have at least two. What's the question at this point is, what's the third angle? Is it right, is it obtuse, or is it a third acute angle? Okay, remember a triangle is made up of 180 degrees. A right angle is 90 degrees. So you can't have two right angles. Already that's 180 degrees. And an obtuse angle is even bigger than a right angle. So there's no way to make more than two obtuse angles and still keep it at 180 degrees. All right, so now let's think about how we would classify these by side length. Okay, one of these names is really easy and the other two people tend to get mixed up. So let's start with the easy one. Equilateral. We know from our Greek and Latin roots that that means equal. Equal obviously means equal. Lateral means side. So an equilateral triangle has three equal or congruent sides. Okay. The next two are isosceles and scalene. I don't have a really great way for remembering which one's which. I've always just noticed the SOS in isosceles, and I thought about a little isosceles triangle that was joined by the two S's, like it had two equal angles right there and two equal sides. Okay, which one is our isosceles triangle? It's this one, the obtuse triangle. So, of course, I cut these out of paper. They're not perfect, but that was the closest I could get. Okay. Finally, our right triangle is our scalene triangle, and a lot of people have trouble understanding that a right triangle can be scalene, but it's very often the case that a right triangle is scalene. You can have an isosceles right triangle, but you cannot have an equilateral right triangle because equilateral triangles have three 60-degree angles. All right, the other thing I want to talk to you guys about today are quadrilaterals. For the quadrilaterals, I've made what's called a hierarchy, okay? And what a hierarchy does is it organizes things into categories. And with quadrilaterals, we start with most general. So the word quadrilateral is as general as we can get. We remember that lateral means side, quad means four, so these are all the four-sided shapes. At the top here are the ones that have the fewest rules, and at the bottom have the most rules, okay? So the top two with the fewest rules are trapezoids and parallelograms. A trapezoid has exactly one set of parallel sides. A parallelogram has two, okay? Which one's the parallelogram? Which one's the trapezoid? This is the trapezoid. This set of sides is parallel. They'll never meet no matter how far we extend them. This is the parallelogram. If we extend both of those sets of sides on forever, it's like railroad tracks. They never meet, like the two L's in parallel. Okay? So I'm going to show you, a lot of people think of a shape like this when they think of a trapezoid. And I think that's partially because of those nice pattern blocks that we all played with in kindergarten and first and maybe even second and third grade that have the nice red trapezoids, and you can put two of them together to make a hexagon. So I have, and Isaac helped me cut some of these. But this is also a trapezoid, okay? It has a right angle, but it still only has one pair of parallel sides. These two sides are not. So a trapezoid can look like this too, all right? I'm going to put our parallelogram here, and then within this category of parallelograms, there's a lot of other shapes. So anything that's below this is also a parallelogram and also a quadrilateral, okay? We know, sorry, very strange noises from upstairs. Parallelograms, we can classify them by either their sides or their angles into something more specific, okay? If a parallelogram has 4 congruent sides, like this one, it's also called a rhombus, okay? If a parallelogram has 4 right angles, like this one, it's also called a rectangle, okay? If something meets all the qualifications to be a parallelogram, the 2 sets of parallel sides, a rectangle, 4 right angles, and a rhombus, 4 equal sides, then it is a square. A square is everything but a trapezoid, because trapezoids have to have exactly 1 set of parallel sides. Okay, so this is how we can organize quadrilaterals. Super specific, lots of rules, fewer rules, only has to have 4 sides. Okay, the last thing we're going to think about on our test is volume. I have not a great way to illustrate this. Okay, I have one of the dictionaries that the 3rd graders got last week. Okay, and I measured it with these little cubes. Okay, these cubes are 1 cubic inch. Okay, and this dictionary is, let's see how well I can show you here. 2 cubes, you can't really see, can you? It's 2 cubes high, and it's 10 cubes long and 7 cubes wide. Okay, so let's remember the formula for area. The length we said is 10 cubes, which are cubic inches, or inches, excuse me, 10 inches long. It's 7 inches wide, and it's 2 inches tall. So we can multiply all 3 of those, okay? And you can do this in any order. Mr. Ward's trying to call. You can do this in any order, okay? I'm going to do 10 times 7 first and then double it because it's easy to double things. So 10 times 7 is 70. 70 times 2 is 140. And remember, my units are always cubic when I do volume. So cubic inches. Inch times inch times inch equals inch to the 3rd power, cubic inches. The other way you can think of it, and it's very similar to what I just did, is you can think of it as base times height. We can think of the cover of this as the base. And we said it was 10 inches long and 7 inches wide. Just like we said, we could say that the base is 70 square inches times the height is 2 inches. We're still going to get the exact same answer. The volume is always going to be 140 cubic inches. Okay. The other thing that you might see tomorrow are composite shapes. Okay. Remember, all you have to do for that is if you have, say you've got a composite shape like this. Okay. It's a rectangular prism, a large one with another one on top of it, okay? And if we magically, here comes a cat, if we magically join these somehow, we wanted to find the volume of both, all we would have to do is find the volume of each one and then add those 2 together. We already found the volume of the dictionary is 140 cubic inches, okay? What would the volume of this be? You can see it's 3, right? 3 cubes is 3 cubic inches. So 140 cubic inches plus 3 cubic inches is going to give you 143 cubic inches. Okay? Get some sleep. See you tomorrow. Be ready for this. Be ready for math. Have a good night.